Now we are going to talk about a very important topic of the analyze phase, which is called the normal distribution. Okay, uh, normal distribution is a very important sort of a topic which give us a lot of information, which help us to take certain decisions also. Okay. In normal distribution, we talk about whether the data that we are going to work on or data which we are working upon is normally distributed or not. Okay. With the help of that, we do a normality test. Normality test tell us whether this data is normal or not normal. If it is normal, it means it's normally distributed. If it is not normal, we would call it as a this is not normally distributed. We can do this test by using graphically or mathematically, and the summary includes calculations for central location, that is mean, median, variance, standard deviation, spread, and a test of normality. Okay, so when do we call the data is normally distributed, and when do we call the data is not normally distributed? That's what we're going to learn. Okay, we would call the data or the piece that we're going to check is normal when the p-value is greater than 0.05. Okay, so we learned earlier about p-value as well, that p-value is the probability value. Okay, probability value talks about whether my data is normally distributed or not. So if my p-value is greater than 0.05 or it's greater or equal to 0.05, then I would say my data is normally distributed. Okay, and in that case I would consider mean as my measure of central tendency, which means that there is no special cause variation observed in this particular data, and that's the reason we say that the data is normally distributed. However, if my p-value is lesser than 0.05, in that case I would consider my data as not normally distributed, or we call it as a not normal data. So that is what the significance of normal versus not normal. And in case of normally distributed, then in that case, if it's not normally distributed, then in that case, we consider median as a measure of central tendency, which means that there are some special cause variation observed in the data, which we need to focus on. And therefore, we would consider median as a measure of central tendency. So that's what we are going to interpret whether the data that we're going to work upon is normally distributed or not normally distributed. And let me tell you that you will do the normality distribution only in that case when your data is continuous in nature. Because when your data is discrete, you want to find any sort of a special causes in it, because majority of the special causes are observed in the continuous sort of data. So if you're doing a project uh, on let's say improving the productivity or improving the customer satisfaction score, where you have scores in percentage or in numbers, so that you know that it's a discrete sort of data. And when you know it's a discrete sort of data, you would never be able to do the normality distribution, because we consider that there is nothing sort of normality or not normality observed in case when your data is discrete in nature. However, if your data is continuous, like let's take an example, average handle time, cycle time, you have data for login hours, you have data for improving the lead time, etc., etc. In that particular case, you would calculate the normality for that particular data. Okay, so we will talk about in detail when we'll do the Minitab exercise, that how to interpret that, how to do this. But it's such a powerful tool. When we calculate normality, we not only calculate or interpret normality. There are other information which you can see here also. We can see the p-value here, which I've just talked about. We will be able to see the mean, the standard deviation, the variance, the minimum, maximum, etc., etc. And with the help of that, we would be able to interpret that which measure of central tendency or which measure of dispersion or spread that I'll have to take into consideration. So this gives a lot of information, and this also gives me kind of a decision criteria that what I need to focus on first. Okay, so I hope everybody is clear with the normal distribution. It is such a perfect, important tool which help us to identify whether is there any special causes observed in the given data. So just to tell you once again that this has to be done only in case when your data, when your project Y, which you're working on, is continuous in nature.